Okay, so in this question we've been given the diagram of a cube and we've been told that the diagonal of the cube D is equal to 48 centimeters. And we have to use this information to find the volume and the surface area of the cube. Now the first thing to say about a cube is that all of the sides in the cube are the same length, and we're going to call this length x. And so it has a length of x, it also has a width of x, and it has a height of x. And our first formula for volume is the length multiplied by the width multiplied by the height. So in other words, in our question, it's going to be x times x times x, which is equal to x cubed. Now, we're going to obviously go and have to solve for x in a minute. We're going to have to find out this value of x so we can sub it into this volume formula. What about the surface area? Well, the surface area of a cube is equal to, well, if you think about one of the faces of a cube is x times x, so the length by the length, or the length squared, that's one of the faces. And in a cube we have 6 faces, so that's 6 by the length squared. And in our question, again, our length is x, that's going to be 6x squared. So the question then changes from a question of finding volumes and surface areas to actually going and finding out what this value of x is. The way we're going to do that is we are going to use the information given that the diagonal D is equal to 48. Now I can see that within that cube we have a right angled triangle that encompasses a hypotenuse of D. Now this right angled triangle consists of one side that is x. So this side here is obviously one of the lengths of the sides of the cube. And then it has a side that goes from one corner over to the other corner. And we don't know the value of this side. I'm going to call it y. The hypotenuse D has been given to us. That's equal to 48. So I have two unknowns in this question, x and y, but I'm still going to form an equation using Pythagoras' theorem. So Pythagoras' theorem works for right angled triangles and said that c squared, the hypotenuse squared, is equal to the sum of the squares of the other two sides. So in our example, 48 squared is equal to x squared plus y squared. Now, as I mentioned, we have two unknowns in this question, so I'm not going to be able to solve for x just with this information. So I'm going to have to use some other information. So I'm going to bring up a triangle on the base of the cube that consists of a right angle in the corner and then two sides of value x, the length of the cube. Now the diagonal of this new triangle that's on the base of the cube is equal to the y measurement in the other triangle that we formed, the green triangle. And so I'm going to use this right angle triangle here, this purple triangle, to find a value for y that I can then sub into, let's say, equation 1, which I've made here. So again, I'm going to use Pythagoras, which says that c squared is equal to a squared plus b squared. And in this purple triangle, c is the hypotenuse y, so y squared equals a is equal to x, so x squared, plus b is equal to x squared. And so y squared equals 2x squared. Now, I don't need to get the square root of both sides in this because I have a value of y squared here, and because I found a value of y squared to be equivalent to 2x squared, I'm going to replace this y squared with this 2x squared in the equation on the left. So going back to equation 1, I have 48 squared, and we'll just leave it as 48 squared for now, we'll convert it in a minute, is equal to x squared plus y squared we found out was 2x squared using the purple right angle triangle. So 48 squared is 2,304, and that's equal to x squared plus 2x squared, which is 3x squared. I'm going to divide both sides by 3 to give me that 768 is equal to x squared, and then x is equal to the square root of 768, which is 16 root 3. So all of the sides of the cube measure 16 root 3. So we're going to sub this value of x back into the two formulas I made previously. So obviously the volume is x times x times x, or x cubed, which in this case is 16 root 3 all to be cubed, and that gives us a value of 21283.44 centimeters cubed. So volume is measured in centimeters cubed. And then for the surface area, likewise, we're going to sub in a value x of 16 root 3. and we get a surface area of 4608 centimeters squared. And remember, surface area is centimeters squared. And so with only one piece of information, that the diagonal of the cube was 48, we found the volume and the surface area of the cube.